Hello class, we're going to be looking at this next unit, which is all about classes. Actually, the next few units we'll be talking about classes. Now, classes fall under this topic of object-oriented programming. And so let me first introduce this idea of object-oriented programming first. Object-oriented programming is a programming paradigm. A paradigm is a fancy word for saying a style or a way of programming. And we have a way of programming, and what we've been doing so far up to this point is what's called a procedural paradigm. And what we do is we create functions, we create procedures that we call to make our program do something. And so this is what we've been predominantly doing so far up to this point of class. Now, a different kind of programming paradigm is what's called an object-oriented programming paradigm. And what it does is it organizes the program as a collection of objects, and these objects interact with each other. And this is a newer kind of style, newer meaning within the last, I don't know, 1990s, 2000 type of thing. Very, very early on, in the advent of the computers, 1950s or whatnot, Fortran, Pascal, C, these were the languages in the 50s, 60s, 70s, going into the 80s. These were the beginning languages, and they all followed the procedural paradigm. It was later on that the object-oriented programming paradigm became more popular, and where it is today, right now, languages like C++, Java, Python, Swift, these are the popular programs. Does that mean that object-oriented programming is way superior than procedural? There's different debaters on that. Some people actually don't like object-oriented programming, that it actually has not really solved any real problems, and it makes things quite messy. But anyways, it's a debatable thing. Today, this is really the predominant style of programming that we're going to be learning and following. There's also another kind, functional programming, which is maybe a paradigm, which is another kind of style or way of programming, and the idea is to use pure functions. And we learned about pure functions recently, where pure functions are functions that do not change any of the inputs that come into it. So these are different paradigms, and I think that object-oriented programming is a nice paradigm. You just have to be, there's difficulties about it, just like any of these paradigms. Now, in Python, all objects, all data types are actually objects. Python, you could say in some sense, is a object-oriented language, in the sense that all data types are objects. Integers, strings, lists, turtles, they're all objects. At the same time, Python isn't completely object-oriented programming language, because you're not required to do everything by use of objects. So there's a bit of flexibility in Python, I guess you could say, to do things in an object-oriented type of way or not. And so it's kind of a hybrid. And anyways, let's talk about objects in Python, or just objects in general. Objects in general contain two components. They contain state information, or another way to say this is characteristics about the object. Another word would be attributes about the object. So these would be things, say for example, in the case of a turtle object, the position, where is it? The direction, what direction is it facing? What color is the turtle? These are all kind of attributes of my object. My object can also do things, and these are methods. And we're familiar with these. The turtle can move forward, the turtle can turn left, we can sort a list, we can append onto a list. These are all different kinds of methods or functions that belong to that particular object. So when we're talking about an object, we're always talking about two kind of things of that object. The state of that object, and again, in the context of a turtle, we have our location, direction, color, and then methods that are owned by that object that we can call with that object. Now, so far, we've only made objects that have been kind of predetermined or pre-made by libraries that we're using. Now we're going to actually make new objects. And when we make a new object, we need to give some sort of instructions on what information that object has, and also what that object can do. So we're going to look at how, when we create our own object, our new object, how do we define state information, attributes about that object, and then how do we define methods? Okay, so let's look at that. And we're going to create a bank account object. And when we do that, we need to define, again, instructions on how to create that object. And that's called creating a class. And a class is like a recipe. A class is like a blueprint. Again, it's instructions on how to make an object and what that object can do. So let's start off just by very basics. We need to define this recipe. And so we start off with this keyword class. I'm defining a new class. I'm defining a new data type called a bank account. And when we make a bank account, we need to create, first of all, what's called a constructor. This is an initializer. A constructor also, an initializer method is called to create this object whenever we want to create a new one. And so in Python, this is the initializer. It's always underscore, underscore, init, underscore, underscore. This is a predefined name, just like class is a predefined word. You cannot change this. This is the name. And this is a required input into that method. Right now, let's not worry about it too much. We'll kind of get into more of it later on. This function, oops, let me go back. This function, init, is called whenever we want to create a new object. And self is just a parameter that's automatically passed to that init function. Again, don't worry about that right now. But just know this. Self is the first parameter that must be in all. Self is the parameter that must be the first parameter of all methods inside of any class. Okay, just kind of know that. And that's kind of weird. And right now I know that you're going to be thinking to yourself, what is self? I don't really understand it, but I'll try to give a bigger idea as we go on in a little bit. Now, we create a new object by calling, in a sense, bank account. This is how we create a new object right here. And what it does is it ends up calling the init. And when it calls the init, what it does is it creates some memory somewhere in the computer. And then it says, okay, there's an owner here, and there's also a balance. So these are the attributes of my bank account. And then I'm going to have my new account variable that points to that object. So far, what you see here is a new class that we made that allows us to create a bank account object. And that bank account object has two attributes. an owner and a balance. That owner right now is just the empty string, and the balance right now is just 0. So it's kind of boring. It doesn't really do too much right now. But we're going to add on to this idea so that we can change the owner to something else, and we can change the balance to something else. But right now I just want to start off with this picture. We have an object with two different attributes, and notice how we access those attributes. We say self.owner, self.balance. In kind of the same way that we did dot notation to call methods, we use a dot notation to access state information about that object. Self is actually, you could say, an alias to that object. And so when we say self.owner, we're getting the owner attribute. When we say self.balance, we're getting the balance attribute of that object right here. So it follows the dot notation when we're accessing attribute information. Okay. So let's add on to this now. So we need to make a more useful constructor, a more useful initializer that actually gives a name to the owner and some sort of dollar amount to the balance. So we're going to add to the initializer, the init method, two other parameters, name and initial deposit, so that the name is given to the owner attribute and the initial deposit is given to the balance. So now when I create my bank account, I give these two parameters here to initialize. And so this is how things would look. Mark would be fed to name, 1000 would be fed and passed to initial deposit, such that when I print out, say, the new account owner or the new account balance, I get Mark and 1000. And so you see here again, I just want you to see the dot notation here. Owner is one of the state attributes, balance is a state attribute, and we can access it with dot notation in Python. And notice it doesn't have the parentheses on the end of it because it's not a function, it's not a method, it's just a variable. Okay? So far we just talked about how we can create a class description that has a couple of attributes. But right now it doesn't do anything. And so let's do the next thing, which is adding some methods. So adding methods is really just a matter of adding functions, adding functions inside of the class. And so we know how to do that already. And the little tiny twist is that the very first parameter always has to be self. And that's weird, but that's just the way Python has kind of defined itself to operate. So that must be the first parameter, and then you could add other parameters on top of it if you want. Now let's look at these first two methods that we're defining, and we call these getter methods. What they do, they're very simple methods. When you call getOwner, it returns the owner attribute. When you call getBalance, it returns the balance attributes. So these are getters. Now they might look kind of silly to do, like why even do this? Because in the previous page, you could see how we just said, new account.owner, new account.balance. Why do I need a getter? Why do I need getter methods? The reason for that is that sometimes maybe you want to actually do a little bit more inside the getter method. You could actually put some other code in here so that maybe in some cases you modify what you return. It's not always self.owner that gets returned, or it's not always self.balance that gets returned, but maybe if your balance is negative, maybe you just say it's 0, or maybe you want to round the balance. And so you could you can kind of modify what this does in your getter method. Another reason is that actually in object-oriented programming, it's kind of frowned upon to have direct access to the attributes. And Python really doesn't protect you from this, but in other languages like Java, you cannot, or they have different protections that kind of prevent you from directly getting into the actual state variables, the attribute variables, and you can't necessarily do this in other languages. And so the only way to get access to information about that attribute is through getters and setters. And so it's a way of protecting the attributes of the object from a programmer accidentally changing things when they really didn't want to, or accessing it in a kind of illegal way. Anyways, let's continue on. Another method here. This one takes an additional input. And so in this case, I want to add money into my bank account. I want to change the balance. So I put in, $50 here, and then $50 gets added onto my balance. So you notice that here, self.owner can be used in other places. Self.balance can be used in other places because I'm sending self as a parameter. And if I'm sending self as a parameter, then I have access to whatever self holds. Now, what is self again? Let me just emphasize this. Self is always going to be a bank account object. And this bank account object has an owner. It has a balance. And so, because self is a bank account, down here in the deposit method here, we're passing to it self. Self is this object over here, so we can access anything inside of it. So we could say self.balance, self.owner in any of these methods. So one of the reasons why we're always passing self as the very first parameter to these methods is so that this method has access to itself and anything inside of it. Okay, so how do we call it now? Well, we already know how to call it. Actually, this is just the dot notation that we've learned. So I have this deposit method, and so now look, we say, we just simply say my account dot deposit. Now, I want to kind of understand what happens when we're calling this now, though. So we have this my account over here with name and balance. This is our object that's created, and this is our variable that points to it. When we say my account dot deposit, my account gets copied into self, and so self then, and then also 500 gets passed into the amount. So this is, another picture of how self is being used. My self is actually an alias. Self points to this exact same object as my account. So then when we start executing this code, we say, okay, self.balance. Okay, what is self? Let's follow the arrow. The arrow points to this object over here, this balance variable. I'm going to add amount to it to change it to 500. So that's what this self attribute is. Self is always the object that you're kind of working upon. Okay. And again, this picture here of passing this value into it could be a helpful kind of picture to help you understand what's happening. So then when we say myaccount.getBalance, we're going to be printing out 1500 here. Okay. Now, I want to end with this little exercise here. And I'll let you read this. It's two parts. The first part is creating the recipe for the class. And then the second part is using it, creating an object. So read this here. Try to do this. I'm going to pause. I'll just count to 3. You can pause this video. And then I'll show the answer to it and talk about it. 1, 2, 3. Okay, so here's the answer. An answer. And I want to highlight a couple things as I talk about this. Number 1, it says to create 2 state variables. And so these are the state variables that I'm referencing. I'm not talking about the input parameters here. I'm talking about the attributes of the rectangle. This instruction said to create 2 variables called side 1 and side 2. These are my attributes, and I can initialize them with any variable input parameters I want to here. Okay. Then later on, I'm calling self, get area, and just notice that I have to supply an input here of self all the time. And so this is my recipe up at top, and then down here, I'm using it. So I'm creating my rectangle here, giving it the name myPoly, and then I'm calling the getArea method and assigning it to this variable here. Okay, so that's it. That's it for this lesson. We'll continue on with more of classes next time. Okay, have a good day, everybody.